The laboratory tests is the flagship of Univet Research and Development Department. This facility is equipped with the most advanced instruments and equipments to perform the tests required by the international standards EN 166 and ANSI. The laboratory is used to support the development of new products, to verify the certification requirements, and for quality control acceptance. The increased robustness test, or more commonly called ball drop, represents the basic testing of the mechanical strength offered by a protective device. This test requires the fall of a steel ball from a height of 130 centimeters, striking the eye protector on the optical centers and on sight protection. After the impact, there must be no fracture or deformation of the lenses and the frame. Resistance to fogging of oculars is tested by using an optical system capable of measuring the period of time necessary to have the lens fogged. Samples shall be conditioned prior to testing by immersion in water for 1 hour, followed by a drying phase at room temperature for a period of 12 hours. The artificial aging test is used to study the behavior of the eyewear following a long-term use by simulating the accelerated aging process suffered from a PPE during its life cycle. The eyewear is inserted in a chamber and exposed for 50 hours to the light of an ultraviolet lamp with a power of 500 watts. After the exposure, the values of light diffusion and luminous transmittance are measured and compared with the previous values from monitoring any changes. The climatic chamber is used to condition the samples before performing impact tests at a given temperature and relative humidity. The EN 166 requires that the impact resistance within the tested extreme temperatures is done on samples conditioned at -5 degrees and +55 degrees Celsius for 1 hour. The capabilities of this machine also allows the verification of performance of PPE to extreme temperatures, such as those that may occur in very cold or very hot environments. Each type of optical radiation source to which workers may be exposed has specific emission characteristics. For this reason, each filter is designed as a function of the emissions from which it must provide protection. The measure of the absorption of an optical filter is done by using an instrument called spectrophotometer, which is capable of measuring the percentage of light that passes through the lens for each value of wavelengths. Eye protectors must not act as a corrective lens in order not to cause visual distortion to the users. For this reason, limits to diopters of lenses mounted on a PPE have been introduced. These limits are by far lower than the lowest dioptric values feasible for normal corrective lenses. The Optical Class 1, owned by Univet products, allows extended use of the device without suffering any visual impairment. A protective device is effective when the operator who wears it is protected from the type of risks to which he is exposed. In case of potential mechanical hazards, it is essential to have the PPE designed with an adequate coverage in order to guarantee the maximum safety to the wearer. The measure of the sharpness of a lens is a crucial step to ensure the best possible vision. Only through a perfectly transparent lens the user is able to effectively perceive the surrounding environment. The bench of the diffuse light is able to measure automatically how much light is scattered from the lens due to its passage through it. Protection against mechanical impacts is one of the most common applications for which a PPE is used. Products designed to protect against any type of collision with solid particles that can hit the worker are tested by impacting them with steel balls of 6 mm in diameter, traveling at different speeds depending on the type of product. For the eyewear, the steel ball travels at a speed of about 160 km per hour, while for the goggle, the steel ball can reach a speed of impact of about 430 km per hour. The ignition resistance of PPE is done by heating a 300 mm long steel bar with a diameter of 6 mm at a temperature of 650 degrees Celsius. The hot bar is then placed on the surface of the test sample for 5 seconds and then removed, ensuring that no part of the protector of the eye ignite or continue to glow after the bar removal. Anti-scratch is a treatment applied to the outer surface of the lens, which constitutes a barrier against the surface damage that can impair vision. Univet lenses are protected against scratches and abrasions caused by solid particulate present in dusty environments or during cleaning actions. Anti-Scratch Plus and UDC coating are certified according to the EN 166 standard through the evaluation of lens abrasion after the fall on them of 4 kilos of quartz sand.